So it's exercise time. So what I want you to do is using these two trees, I should say really this single tree here, is I want you to go ahead and do the next two deletions from this tree here. So after you're done with that, I want to see the resulting tree, and we'll go over that here in a second. I want you to also take a look at your delete function. Are we placing data back into the same array, or are we placing it into another or new vector? So take a look at the delete function and we'll go over the answer with that as well. So here is our solution for deleting the next two values. Now remember, there's only one spot that we can delete from in the heap, and that's always going to be the topmost node, which is the min heap, so it's going to be the lowest value of the entire heap that we've got. So if we're going to go ahead and remove the next one, take it out of there, and then we're going to replace it with the 59 that was, again, at this last spot. Now again, this could have been any value, 59, whatever the value was at the very end, that's what it gets replaced with. So after we do that, we go ahead and look at the two children, and again, remember, the lowest value needs to be, well, the parent. So we need to switch or swap 59 and 53, since that is the lowest out of those two values. So we've identified that. Go ahead and do the swap, and voila, done. We're going to take a look at 59 and check to see if its kids are any less. Nope. So we're good. And we don't do any swaps there because 97 was in the correct spot already. So that's our first solution for our first delete. Let's do our second one. Same idea. We get rid of 53. Now again, the only one that's left over is that 97. So that's how we know what to do next. So we're going to move that 97 into place. Look at the two kids, see if either of them are less than, which both of them happen to be. We're going to grab the lesser of the two, which is the 58, and then go ahead and do a swap. And we would check here, but again, to be honest, there's nothing below, there's no kids. So I don't want you to think it just ends because it happened to end, but it would still check, realize there's no kids, and then stop at that point. And that is our solution for our two deletes from our minimum heap. So in this last portion of our exercise, it's really inconclusive. Matter of fact, I'm really actually genuinely surprised that, well, in Java, they go ahead and return the item, which means, well, frankly, we don't know what it's going to be returning to, but that's the minimum item at the location. After that, though, frankly, we're not sure what it does in C++. We can reflect it and do the exact same thing in Java with some easy code adjustments. But in reality, there's no concrete answer on exactly what we do with the values that we return from. So that's going to have to something to be careful about if you get something assigned with the code in heaps. Make sure you know what you do with that deleted value that you are deleting and then replacing eventually with another value to the next minimum value in the heap, in a minimum heap.